Welcome to The Explainer. I am absolutely thrilled to be your guide today as we decode one of the most fascinating pieces of modern system design. We're going to focus on demystifying real-time web communication. Specifically, we are breaking down a technology that literally powers the interactive web we use every single day. We're answering the big question, what exactly is a WebSocket?
Okay, let's dive right into this. Have you ever actually stopped to think about this fundamental paradox? Because if web browsers are inherently designed to only ask for data, just waiting patiently for a response, how do real-time applications like instant messaging actually work? I mean, it kind of feels like magic, right? A server can't just randomly tap a client on the shoulder whenever it wants. Or, well, can it?
So here's our game plan for this explainer. We'll start with the core real-time web problem. Look at some early workarounds like polling. Introduce the WebSocket itself, explain exactly how it works under the hood, compare it to other protocols, and finally, outline when you should actually be using it in your own systems.
All right, let's kick things off with Section 1, the real-time web problem.
So the fundamental issue here is that traditional client-server communication, like your standard REST architecture operating over HTTP, is strictly client-initiated. The browser has to literally pull data from the server. You want a web page, you ask for it, and the server gives it to you. That works flawlessly for, say, loading a document, but it creates a massive hurdle when the server needs to be the one initiating contact. Imagine if the only way you could ever get your mail was by constantly walking down to the post office and asking if there was a letter for you. It's just not efficient.
Moving right along to Section 2, workarounds, and how we basically tried faking real time.
Back in the day, one of the earliest techniques developers used to fake a server-initiated connection was called polling. By definition, polling is when the client just periodically asks the server, "Hey, are there any new messages?" over and over again. Now, depending on how often you're asking, this gets incredibly costly. It just chews through precious server resources just to repeatedly answer the question with a no. It is literally exactly like a kid sitting on the backseat of a car asking, "Are we there yet?" every 30 seconds.
Now, looking at this architecture comparison, contrasting webhooks with polling really highlights the issue. While polling forces those continuous, resource-heavy checks against the system, a webhook operates totally differently. A webhook is an asynchronous, event-driven callback. So for example, your system tells an external processor like Stripe, "Hey, call me back when this payment is done." It waits patiently, rather than constantly shouting into the void. But while webhooks are amazing for server-to-server events, they still don't solve our fast-paced client-server chat problem.
Which brings us to the star of the show, Section 3, enter the WebSocket.
So, what is a WebSocket really? Well, it provides what the source material calls full duplex communication. And honestly, this was a massive shift in how we build things. Full duplex means it establishes a persistent, bidirectional communication channel over a single TCP connection. Think of it like a two-way radio that is just always left on. Data flows in both directions simultaneously, and crucially, the client doesn't have to ask for permission first.
To boil it down as simply as possible, standard REST and HTTP architectures are entirely focused on pulling data. You request it, you get it. WebSockets completely flip that dynamic on its head. They empower the server to actively push real-time updates straight to the client the absolute millisecond they happen.
Okay, let's pop the hood. Section 4, how WebSockets actually work.
Setting up this persistent connection is actually surprisingly elegant. WebSockets cleverly start their life as just a standard HTTP connection. This is such a smart design choice because it easily bypasses standard corporate firewalls that are already set up to allow traffic on ports 80 or 443. So first, the client initiates that standard connection. Second, a well-defined handshake occurs. Third, the connection gets formally upgraded. And fourth, the bidirectional messaging finally begins.
You can see it perfectly mapped out right here. The client fires off a GET request with a WS endpoint, that HTTP handshake hits the server, and then the server shoots back an acknowledgement. From that exact point forward, the standard connection turns into this persistent bidirectional channel. The initial HTTP connection has been upgraded, and the real-time data pipe is just wide open.
So where does this fit into the bigger picture? Let's look at Section 5, WebSockets versus other protocols.
Looking at this matrix, we've got some great context. We have RESTful APIs, which are ideal for your standard web services, where you're just pulling data. GraphQL lets you request very specific data to cut down on network overhead. Then there's gRPC, which is high performance, uses protocol buffers, and is just fantastic for microservices architectures. Webhooks, like we saw earlier, handle those asynchronous event callbacks. And finally, WebSocket. Notice its key characteristic. It is strictly designed for real-time, bidirectional, persistent, low-latency data exchange. Let's bring this all back to the real world. Section 6. When to actually use WebSockets. WebSockets are incredibly powerful, but they definitely have very specific, ideal use cases. Think about online gaming, where literally a split second of latency means game over. Or stock trading platforms, where prices absolutely must update the instant the market fluctuates. They are the backbone of modern messaging and chat apps. Even those little online presence indicators, the green dots next to a user's profile showing they're online, they rely heavily on the persistent connection of WebSockets to instantly push that status out to everyone.
Fun fact here, early chat apps actually used standard HTTP on the sender side because, well, it's technically fine for just throwing a message up to the server. But by utilizing WebSockets for both the sender and the receiver, the entire system design is vastly simplified. You can see how the sender pushes a message up through their WebSocket, and the server instantly pushes it right down to the receiver through theirs. It's so clean and incredibly straightforward to implement.
But, and this is a big but, WebSockets are not a silver bullet. Take Google Drive, for example. If you're collaborating on a document with someone, it actually relies on long polling, not WebSockets, for those file change notifications. Why? Because file updates are relatively infrequent compared to a rapid-fire group chat. It simply doesn't need constant real-time bidirectional data bursts. WebSockets require serious server resources to keep those connections open, so it's always best to reserve them for when you strictly need that real-time push.
Which brings me to a final provocative thought for you to chew on today. As you evaluate your own system designs, I want you to ask yourself, are your applications truly real-time, actually leveraging the power of push data, or are they just inefficiently polling in the dark? Truly understanding the massive leap from polling to pushing is your key to designing much better systems. Thank you so much for joining me on this explainer. I really hope this sparks some great ideas for you, and I will catch you next time.